Today we'll solve a nice problem based on the greatest integer function. Let's begin. This is a given question. We need to evaluate sum of the greatest integer values of root 1, root 2, root 3 and so on root 120. And what they given greatest integer function of alpha less than or equal to alpha. Suppose if you take n as 1, 2, 3 and so on up to 120. Here notice that the integer part of this root n remains the same with certain ranges. The value of square root of n changes. When it changes, if you do a perfect square, then the value n is changes. It changes but remains the same within certain ranges. So we need to take those ranges. If you take a range from 1 square to 2 square, means so you need to take 1 less than or equal to n less than 4. Here how many n values are there? So n values are, here we are taking less than or equal to, that means n value is 1 and 4 less than values which are 2, 3. If you take a range from 1 square to 2 square, so the n values are 1, 2, 3. Now if you take n as 2 and take ranges between 2 square to 3 square, how can you write this? We can write this as 2 square is nothing but 4. 4 less than or equal to n less than this 3 power 2. The value is 9. So here what are the n values? N values are, so here also we have a equal to, less than or equal to. So that's why you have to start from 4. Then 5, 6, 7. Here we have a 9 less than. N less than 9 is nothing but we need to take up to 8. Here we are considering n as 1. So how many terms we are getting? We are getting 3 terms. Here n is 2. How many terms we are getting? 1, 2, 3, 4, 5. For n is, when you take n is 2, we are getting 5 terms. Let's check for the 3. In between range is 3 power 2 to 4 power 2. So that means we need to take 3 power 2 is nothing but 9. So we need to take 9 less than or equal to n less than 16. 4 power 2 is nothing but 16. So let's take 16. Here how many values we are going to get? We have to start from 9. Then here we have 16. So we have to take up to 15. So 9, 10, 11, 12, 13, 14, 15. Here we are getting 7 terms. This is our first method. Without using any formula, I am going to find the solution. We are not using any formulas. So like that we are continuously take up to certain dates in between 120. Next we need to take n as 4. 4 power 2 less than or equal to n and less than 5 power 2. 4 power 2 is nothing but 16. 5 power 2 is nothing but 25. So the n values are, we have to start from 16 to, here we have 25. So you need to take up to 24. So here we are getting 9 terms. We are going to take 5, which is 5 power 2 less than or equal to n less than 6 power 2. So 5 power 2 is nothing but 25. 6 power 2 is nothing but 36. So now we are taking this range. How many terms we are going to get? We have to start from 25 and keep on go up to here 36. So you have to go up to 35. Here we are going to get 11 terms. So like that we are going to take n equal to 6. So which is 6 square, that is 36 less than or equal to n less than 49. So now we are taking the range in between 36 to 49. So here how many terms we are going to get? We have to start from 36 and here 49. So you take up to 48. So when n equal to 6, we are going to get 13 terms. N equal to 7. So here we need to take 49 less than or equal to n less than, this is 7 power 2 and here we need to take 8 power 2. That means here we need to take 64. Here we need to take n as 49, 50, 51, 52 up to so on up to 63. So here we are getting 15 terms. Now you need to take n as 8. So here we have 64 less than or equal to n less than, next square number is 81. So here we are getting n as 17 terms. Let's take n as 9. That means you need to take 9 power 2 less than equal to n less than 10 power 2. So 9 power 2 is nothing but 81. 10 power 2 is nothing but 100. Here we are getting 100. The given question is up to 120. So 120, this perfect square lies in between 10 square and 11 square. 11 square is 121 and 10 square is 100. So we need to take n value up to 10 square to 11 square. That means we need to take n as up to 10. So this is 9 only. Still we need to do one more step. So here the n values are 81, 82 up to so on 99. So here we are going to get 19 terms. So next n equal to 10. That means 10 square, which is 100, less than or equal to n, less than 11 square, which is 121. So here we are going to take n as 100, 101 up to so on. Here 121, the less than value is 120. So we are taking 100 up to 120. So our given question also is up to 120. So we are done up to here. So just we need to take the term, how many terms we are getting here. Here we are going to get 21 terms. When we are taking n as 1, how many terms we are getting? When you take n as 1, we are getting 3 terms. So we need to write 1, the number 1, 3 terms. Then if you take n as 2, we are getting 5 terms. That means you need to write 2 5 times. So if you take 3, we are getting 7 terms. So that means you need to write 3 as 7 times. So like that we need to keep on write up to 10. We have 1 as 3 terms. So we can write this as 1 times 3. Here we are, for the number 2, we are getting 5 terms. So we can write this as 2 times 5. For the number 3, we are getting 7 times. This we can write as 3 times 7. Like that, 4, for the 4, we are getting 9 terms. So we can write this as 4 times 9. Then the number 5, how many times? The number 5 we are getting 11 times. Write this as 5 times 11. Now let's check for the 6. 6 we are getting 13 terms. 7 we are getting 15 terms, and 8 17 terms, and 9 we are getting 19 terms. Then last 10 we are getting 21 terms. What we do now is simply multiply and add all these numbers. 1 times 3 is 3. Let's take 3 plus 2 times 5 is 10. 3 times 7 is 21. 4 times 9 is 36. 5 times 11 is 55. 6 times 13 is 78. 7 times 15 is 105. 8 times 17 is 136. 9 times 19 is 171. And the last one, 10 times 21 is 210. After adding all, then we are going to get 825. This is the result of the greatest integer function of root 1, greatest integer function of root 2, and so on up to greatest integer function of 120. So without using any formula, using only this square root and greatest integer function concept, I solved this problem. Now the same problem using formula, how can we do it? Let's see that. So if you want to use the formula, just observe the terms. What we have square root of 1, square root of 2, and so on up to square root of 120. Here also we need to take certain ranges, and also you need to take this certain ranges in between greatest integer function of n less than or equal to n, like that you need to take. So for the 1, we are taking 1 square less than or equal to n less than 2 square. So here we are getting 3 terms, isn't it? Just now we seen it. Similarly, we need to take up to 120 terms. So for the 2, we are getting 5 terms. So and we need to write up to so on 10 power 2 less than or equal to n and less than 11 power 2. So here we are getting 21 terms. Now let's write the general term. So we are considering root n as k. So if you do square on both sides, so then n equal to k power 2. Now observe the left hand side. We have a 1 power 2 is nothing but we are taking n as 1. So the general form of this series is, we can write this as k power 2 less than or equal to n less than, if you consider this as k, then here we have a 2, that means k plus 1 whole power 2. So now we need to find number of terms in the group. To find the number of terms in this group, so we need to do k plus 1 whole square minus k power 2. Then k plus 1, it is in the form of a plus b whole square. If you expand this, we are going to get k power 2 plus 1 plus 2k, and still we have minus k power 2, and here these two gets cancelled, so we left only 2k plus 1. This is the general term, but we need to contribute from each k. So that's why you need to take k times 2k plus 1. So finally we got a general form for this series. So using this, let's take the summation, then we can find out. So we are taking n up to 10 So that's why the summation also we need to take from 1 to 10. So summation k equal to 1 to 10, k times 2k plus 1. If you expand this, k times 2k, which is 2k square, plus k times 1, which is k. So 2k square plus k. If you split this, so 2 times summation of k equal to 1 to 10 times k power 2 plus summation k equal to 1 to 10 k. Now you need to recall the formulas. So what is the summation of k power 2 formula? So summation of n power 2, the formula is n times n plus 1 times 2n plus 1 over 6. So what is the summation of k? The formula is summation of n, that is equal to n times n plus 1 over 2. So these are the formulas. So let's use that. So that is equal to 2 times k power 2, the formula is n times n plus 1, 2n plus 1. So you can write this as k times k plus 1 times 2k plus 1 over 6. Here k we are taking up to 10, isn't it? So let's substitute k as 10 here. So if we substitute k as 10, so here you need to write 10 here. Here 10 plus 1, which gives 11. And here 2 times 10, which is 20. 20 plus 1, 21 over 6 plus. Now we need to substitute this summation of k n formula, which is n times n plus 1 over 2. So we are taking k as 10. K is up to 10. So let's take k times k plus 1 over 2. So we are taking up to 10. That's why you need to take k as 10. So k is 10. So 10 plus 1 is nothing but 11. After cancelling, then here we are going to get 55. And here 3 7s are 21. So here we are going to get 11 times 7 is 77. 70 times 10 is 770. So after adding, we are going to get 825. So using formulas, we can find like this. Otherwise, we can do directly. So if you like this content, like, share, subscribe to my channel. Thank you for watching.